Okay, this is our third of 3 lessons on area. In our first lesson, we just basically talked about what area is. And we learned that area is the number of squares required to cover a two-dimensional object. And we went around and we laid grids over the top of two-dimensional objects, and we took 1 foot by 1 foot squares with us and used it to estimate areas. And we just got a feel for what does area mean, and we learned that the size of the square matters, and we learned that it's really important that we tell people that we're using squares to measure things. Now, we also learned that using a grid to measure area and carrying a square around with us to measure area is just not a really efficient thing to do. So in our second lesson, we talked about how we typically calculate area, and we learned that we usually calculate area by using area formulas. And we learned a handful of very important formulas. We talked about rectangles and triangles, and we learned that the formula for the area of a rectangle is equal to length times width. And we've learned that the formula for the area of a triangle is base times height divided by 2. And we learned that the formula for the area of a parallelogram is base times height. And the formula for the area of a trapezoid is base 1 plus base 2 times height divided by 2. And ultimately, what we learned is that every one of these formulas comes back to the formula for the area of a rectangle. We can turn a parallelogram into a rectangle by chopping off one triangle and moving it to the other side. We can turn a triangle into a parallelogram, and we can turn a trapezoid into a parallelogram. So all these formulas are related. In addition, I forgot to put one on here, we learned that the formula for the area of a circle can be found by taking the, let's do this right, can be found by taking the area or the radius of a circle and multiplying it by pi, or I'm sorry, the radius squared and multiplying by pi. So the formula for the area of a circle is pi r squared. Okay, so we've got all these different formulas that we can use to measure area. How many squares does it take to cover a two-dimensional object? Now, most objects in real life are not perfect rectangles or perfect triangles or perfect parallelograms, trapezoids, or circles. Usually it's more complicated than that. So the focus of this lesson is to look at how do we measure the area of irregularly shaped objects, which is what we usually see in real life. So here's an example. It's a pretty simple example, but here's an example of an object that's not a rectangle, it's not a square, it's not a circle, it's not a triangle or trapezoid, but we can still find the area. Now, when we look at an irregular object like this, there's usually 2 ways that we can go about figuring out the area, and I'm going to show you the 2 different ways right now. One way that we can figure out the area of an irregular shaped object is by using addition. So if I look at this particular shape, I can take the shape and I can draw a rectangle right here, and I can draw another rectangle right here. And if I were to add the area of those 2 rectangles together, it would give me the area of this shape. So if I take both of these rectangles over here and I just label what I know about them, I know that this is 10 feet and this is 28 feet. I can figure out the area of that rectangle. Now if I go over here, what do I know? Well, I know that this is 17 feet, but I really need to figure out what is the measure of this side right here. That side's the same thing as this side over here, and I'm pretty sure I can figure that out because if I use my segment addition postulate, I know that 30 minus 10 is 20 feet. This is going to be 20 feet right here. All right? I can figure out the area of each of these objects by using the formula length times width. I like to write down the formula that I'm going to use every time I figure out an area. So if I look at this, I can see that the area of this very first blue rectangle is 28 times 10, which is 280 square feet. Don't forget the square. The red triangle has an area, doesn't seem like it's going to be right, but 20 times 17 is 340 square feet. And if I add the two together, my final area is going to be 280 plus 340, which turns out to be 620 square feet. So I found the area of this particular object by using addition as a strategy. So what I'm going to do right now is this. I'm going to, I'm going to try to at least group all this stuff together right now and make it a little bit smaller so that I can get it out of the way. Okay. Because I'd like to show you my second strategy for finding the area. Sometimes when you find areas of irregular shaped objects, what you like to do is instead of using addition, you actually like to use a strategy that is very similar. It is called subtraction. Subtraction works like this. If I take a look at this object, I see this really big rectangle right here. Okay. Now that rectangle, the area of that rectangle is bigger than the area of the shape that I'm looking for. But if I look closer, I can see this little tiny rectangle up here. And if I were to take that red rectangle away from the blue rectangle, what I'm going to end up getting is the area of the shape that's left over. So what I'm going to do is this. I'm going to bring this blue rectangle down here. I'm going to bring this red rectangle down here. I'm going to label them. Okay, what do I know? Well, I know that the blue rectangle has dimensions 28 by 30. So I'm going to write that in here. Now the red rectangle is a little bit different because I don't know any of its dimensions. Actually, I do know one because in the last problem, I figured out that this was 20 right here. And if I do the same type of thing over here, if I look at my 28 and my 17, I can subtract those and I can see that that's 11. So when I look at my red rectangle, this is an 11 by 20 rectangle. So now let's see what happens. If I find the area of the blue rectangle, the area is going to be length times width, which is going to be 28 times 30, which, as it turns out, is 840 square feet. The red rectangle, the area is length times width, which is 11 times 20, which, as it turns out, is 220 square feet. So what do? In this case, my area can be found by subtracting the two. And if I take 840 minus 220, I get 620 square feet, which, as it turns out, is the exact same thing that I got up here when I did my area by addition. So, typically, problems that you see in real life are going to require you to either add or subtract the area of other shapes together to find your final area. Okay? Here's another kind of typical problem that you might see. Our goal here is to figure out the area of the shaded portion of this diagram. Now, if I take a look at this diagram, so, all I'm interested in is the area of this shaded stuff that I see in here. That's not a common shape. But what I'm seeing when I look at this problem, I'm seeing two common shapes. I'm seeing this rectangle right here. And if I were to find the area of that rectangle, I'm going to shade it in so you can see it. If I were to find the area of the rectangle, that's obviously way too much, okay? Because I've got those circles inside. But what I can do is I can take a look at those circles, and I can find the area of each one of these circles in here. And what I'm going to do is I'm going to subtract the area of those circles away from the area of the rectangle. And when I do that, I'm going to end up with that shaded area that's left over. So I'm going to find area by subtraction. So what I'm going to do is I'm going to pull this rectangle out like this, and I'm going to label its dimensions. I know that this rectangle is a 6 by 18 rectangle. Now, I'm going to be smart about this. I don't need to find the area of all of these circles. I really only need to find the area of one of these circles. So if I were to draw one of these circles in like this and bring it out like this, all I really need to do is think, okay, how do I find the area of a circle? This one's a little bit tricky. Okay, I have to be careful. I have to remember that the formula for the area of a circle is pi times radius squared. That's my formula. Just talked about that. So I have to think, what's the radius of this circle? Well, I know that the distance all the way across the circle is 6. That means that my radius from the middle out is going to be 3 inches. So I think I'm ready to go. The area of my rectangle is going to be 18 times 6, which is 108 square inches. That's the area of my rectangle. What's the area of my circle? The area of my circle is pi times 3 squared. I think I need my calculator to kind of figure out what that is. So I'll bring up the calculator. I'll do 3.14 times 3 times 3. That's 3 squared. What do I get? 28.26. So this area is approximately 28.26. But now remember, I've got 3 of those circles. So the final area that I'm looking for, the area of the shaded piece, is going to be the area of the rectangle. That was 108. But I have to subtract 3 circles. So I'm going to subtract 3 times 28.26. Get the calculator out. Times that answer by 3. What do I get? 84.78. So this is going to be 84.78, and I'm going to subtract that from 108. And when I do that, I am going to get a total of, I think I should be able to do this in my head. What am I going to get? I'm going to get 23.22 square inches. So this is a case where I'm going to find my area by subtraction, because the shaded area can be found by taking 3 circles away from a rectangle. All right, I've got one more example that we need to look at, because sometimes you don't use subtraction or addition. Sometimes you have to use both of them. We're going to find the area of this object that you see in front of you right here. Okay, it's a strange looking object, but if you look at it, this is what I'm seeing. What I'm seeing right now is this. I'm seeing this rectangle right here. But that rectangle is too much. The other thing I'm seeing is this semicircle. I need to take that semicircle away from the rectangle because it's not part of the picture. But not only do I see a rectangle in the semicircle, I also see a triangle. That needs to get added on as far as the area goes. So I have 3 different shapes I need to find the area of. I've got this rectangle, which if I look at it, has dimensions 30 by 20. I've got this semicircle, which if I remember, that's half a circle. And what's really important in a circle, if you remember, is the radius. Well, if the distance all the way across is 20, then the radius has to be 10. And then I've got this triangle down here. In this triangle, the thing that is important is the base, which is 20, and the height, which is 25. So what do I have to do? I have to find the area of each of these figures. The area of a rectangle is length times width, which in this case is 20 times 30, which in this case is 600 centimeters squared. The area of a semicircle is going to be pi times radius squared. But I have to take that answer. It's only half a circle, so I got to divide it by 2. So what is that? That's pi times 10 squared divided by 2. This is a calculator problem. So I go to my calculator. I've got pi times 10 squared, which means times 10 times 10 times 10. Take that answer, and I've got to divide it by 2. So the area of that semicircle is about 157 square centimeters. And then finally, I've got my triangle. And my area of my triangle is base times height divided by 2, which in this case is 20. That's the base. The height is 25. Divide that by 2. Now I know 20 times 25 is 500, and if I divide that by 2, I get 250 centimeters squared. So what's my bottom line? I've got to take my area, my final area, is going to be the area of my rectangle, minus my semicircle, plus my triangle. And if I put it all together and do the hokey pokey and turn myself about, I should get my answer. You actually don't have to do the hokey pokey if you don't want to. 600 minus 157 is that, and I add on 250, and I get a total of 693 square centimeters for my area. It's a little bit more of a complicated problem because you have to be able to look at that picture and figure out, got to do some adding, got to do some subtracting. So the moral of the story is this. Typical real life problems, and you're looking at these and you're like, well, why is this real life? I'll show you some examples as we go along of why this is more real life. But typical real life problems require you to be able to add and subtract the area of a variety of different shapes. And that's what we're going to be practicing in area assignment number 3.